Let's move to our final and sixth presentation by Sebastian Lenzner for a paper entitled Decision-Based Data Distribution, Enabling Users to Minimize Data Propagation in Privacy-Sensitive Scenarios. Okay.
Yeah, thanks for the introduction. This is a joint work with my colleagues Kilian Demuth, Marc Fischlin, and Christian Reuter. And our work is motivated by the fact that some companies share their secret keys with mailboxes or firewalls for malware checks, but this ultimately weakens end-to-end encryption. And on the other hand, client-side encryption has usability issues. According to Google, for instance, encrypted emails cannot be used for search options or malware filtering. And our approach aims to use layered encryption to provide a trade-off between privacy and usability. Users can decide which information is sensitive and add an additional layer of protection to it, and all non-sensitive information is transferred as usual and then can be used for search option or other things. To go more into detail, we're utilizing the stealth protocol of Fischlin, and that basically allows us to generate two pairs of keys in one single TLS handshake while providing the deniability to an attacker that can monitor the network traffic that he cannot distinguish whether the second key was generated or not. We have several assumptions for this model. We assume that there's some kind of email client or email client extension or even a mobile app to provide the ability to store the keys and process them, and also have an authentication mechanism attached to it so that the user can be identified. The reason behind this is we want that no sensitive information is stored in plain text, and the user has to be authenticated within the app and then manually decide to decrypt the data so that it's temporarily available. The overarching use context of our system is online forms, because many companies and organizations already use them, and the backend could be changed. From our pre-study, we derived that the most utilizable use case would be the communication with medical offices. So we designed two demonstrators, a non-customizable version and a customizable version, to get some insight onto the control paradox. First, we see the online form for the non-customizable version, how a patient would see it. It's just some personal information text, how the system works. And then there are two input fields. One is without additional protection, and one offers additional protection for sensitive information. This is a view for the doctor. It's similar. The doctor can see the patient data, has a different information text that says that the highlighted information is considered sensitive by the users and therefore should be used with care. First of all, because the user is very concerned about this, and secondly, this information is not checked by a firewall, so if there's a link or something in it, treat it with care. And thirdly, this is an answer that the patient receives. And as you can see, the sensitive information is not displayed. It's hidden behind a button in this case. And we assume that when the user is authenticated and then decides to decrypt the data, it's temporarily decrypted and shown, so that even on the own device of the user, the sensible information is never stored in plain text, just for use cases like shoulder surfing or shared devices. On the other hand, this is the customizable version. As you can see, the second text area is missing, and the controls are moved to the right. So the user can decide for every piece of data if it should be only visible for the doctor or if all the other staff members can see it. Again, this is the doctor's perspective, and again, the sensible information is highlighted. And again, the answer shows only the non-sensible information, while the information that uses the additional encryption is not shown. We then conducted a qualitative user study with both demonstrators. We interviewed 42 participants and with hands-on experiments on both demonstrators. And here are some selected results. First of all, what are the reasons why users prefer the non-customizable version? Users said there was the possibility to misclick in the configurable version, and that making those decisions would cause overload, or Some said that the separate input fields for the non-sensitive and sensitive information would provide a clear separation, and this would be intuitive for them. Some favored that there were less clicks, and many were really curious to hide too much information. They were afraid in the customizable version that they would protect information that would be actually usable for the staff members to process the order, and that by encrypting that data, their order or their request might be delayed or even failed, and it would be a burden to staff members. On the other hand, these are the reasons for preferring the customizable versions. Again, some people perceive this as intuitive and fast, while perceiving the non-customized version as cumbersome because there are two tags for different addressees, and it was perceived redundant, and some were afraid that if they misperceive the two input fields, then data could be leaked unintentionally. Therefore, they thought the customizable version would offer better guidance, and even the possibility to hide the personal information, which is not possible in the non-customizable version. Furthermore, we saw that the mental model of the users were affected because due to the option to customize their privacy, they had the feeling that they are giving the data away voluntarily, while in the non-customizable version, they had the feeling that the data is extracted from them, that they are forced to give it away, and just by having the choice, they had a better feeling. And we also received the feedback that the overhead for clicking the checkboxes would not be a hindrance for usage. One of the main benefits of our solution is that there's increased privacy at home and in the medical office. By not showing sensitive information, problems like shoulder surfing or shared devices are addressed, and we investigated which use cases might be especially relevant for this protocol. First, I'm going to present the use cases for the increased privacy at home. What often was mentioned is that in the medical context, a patient might receive severe diagnosis like cancer or other lethal illnesses, and that they want to cope with this diagnosis and process it themselves before then deciding if and with whom to share it. And our mechanism would help them by hiding this information from others. The next reasons could be categorized as housing situation. For example, if there's mistrust at home, or if parents want to protect their children from the diagnosis that they are getting, or if children want to be protected from their parents. Especially for young women, it is a problem because some participants reported that they had a hard time getting to the gynecologist at a teenage girl because their parents didn't believe in this. So it was very hard for them. Then there is the issue of shared flats where maybe also devices are shared, or shoulder surfing is an issue. One participant mentioned that if someone has a divorce but they're still living together, this is also a good use case for increased privacy, and for participants also mentioned domestic violence. The next topic is intimate topics revolving about pregnancy, planned or unplanned, getting results from the urologist, which could be very sensitive, or abortion. Then there are taboos and stigmatized topics. Most participants just said there's the general topic, but some were more specific by mentioning sexual transmittable infections or psychological issues like depressions. There also was concerns about drug abuse, including alcohol, or even help for suicidal people. Some participants also mentioned the fear of discrimination. As one participant stated, it contains everything that would prevent him from living on his life as he lived before. Some others were more specific, like LGBTQ topics or disablement. Other reasons could be categorized as school topics, for example, protecting the communication between teachers and parents, or pupils and teachers, transmitting legal documents, or some stated religious reasons where maybe they cannot talk with their families about their beliefs, and then they want to have a secure communication with someone to give them advice. Next are the use cases for the increased privacy in medical offices. And again, this resolved about sensible topics, like intimate topics, psychological issues, or taboos or stigmatized topics. And another big topic were social aspects. Many participants mentioned that living in rural towns or areas where everybody knows each other, it's sometimes hard to go to the doctor because you are seen and then people might spread rumors. And one participant even stated if that her grandfather is not going to the doctor because he's so afraid of the rumors. Then the next point is that relatives or acquaintances might work within the medical office, which is a huge issue for many participants. And one participant even stated that if he knew that someone he knows worked there, he would go to a different medical office. Of course, this is a luxury that not everybody has. And then there is the fear of using the telephone. This does not only include the telephone anxiety, but also the fear of eavesdroppers. For example, if you call a medical office and the person at the front desk picks up, and then maybe they talk to you and there's personal information or information about your health status leaked, and other patient may eavesdrop on it. There was one participant that stated that a friend of hers stated her name and birth date at the front desk, which is usual in Germany to identify a patient. And this information was observed by a bystander, and this person then used that information to find her on social media and contact her. To conclude, in our paper, we presented a design for an interaction concept that increases privacy and enhancing communication in C2B scenarios. We utilize a stealth protocol to achieve deniability of key creation, which could be relevant for sensitive use cases where the communication has to be hidden. The solution is suitable for different use cases, and we investigated on a specific use case, the use case of medical offices, and we showed that this tool can reduce social barriers to seek help, and even the form-based communication is an improvement to the current status quo. One particular interesting finding is that giving control to users affect their mental models and thus the way they disclose data, which could be contribute to the discussion around the control paradox. Because users feel not forced to give the data away, by feeling in control, they deliberately give the data away, or as some of our participants stated, everything they did not encrypt, they decided not to encrypt. Our study is subject to some limitations. First of all, not all findings are exclusive for our solutions. There might be other solutions that achieve the same things. But we can show that even those people who do not care about the privacy or never even thought about it have benefits by using our solution. And our evaluation was of qualitative nature, which means that it's not necessarily representative for all populations. With this, I want to conclude my talk, and if you're interested to play around with the demonstrators or modify them for your own purposes, feel free to use the QR code or approach me here at PETS. Thank you.
Thank you very much. Are there any questions? Okay. I have a question for you. What next steps for this research you plan to take?
Yeah, this was a first step of creating the concept and asking users if they're actually interested in it. We were considering doing implementations or going to experts, but we discarded that because doctors, lawyers, or social workers are very busy, and it's quite hard to get to them. And when they offer their time and work for a study, and then we implement it and make a tool, and then we see the end users don't want it, then it was all to waste. So this was the first step, and one of the next steps would be going to the experts or professions that handle sensitive data, or companies that are afraid of data breaches and want additional protection. And follow-up study with experts, and implementations for different use cases depending on the expert interviews. And
Okay, thank you. We have a question.
When you decide to encrypt for a doctor's eyes only, then you would need to know exactly which doctor you want to visit or contact. Is that right?
This is the reason why we have the overarching use context of online forms. First of all, online forms are structured data that allow easily for taking parts of it for additional encryption. And the vision is that there's some kind of editor that every doctor, every office, every company can design own forms for their website. Many already have forms on their websites that can be utilized. And as you can see in this, for example, here, in this form, we had an option where to choose the doctor. In Germany, it's the case that sometimes there are medical offices where multiple doctors are working, and usually a patient has one doctor that is the main doctor as a Hausarzt in German, and you can select them in this form, and then the key would generate it between the two. Does this address the question?
Okay. With that, we conclude this session. I thank all the speakers and I thank all the attendees for their time. Thank you very much, and see you.